Hello, we are Foxdog Studios. My name is Pete. This over here is my colleague Lloyd. We create and perform comedy shows online and in the real world live. Today we're going to be taking you through the creation of a brand new game for our website. We're going to be creating it within 24 hours. So as you can expect, this video will last 24 hours.
So this won't be live, but we will be live in the chat, able to answer any questions you have and defend any choices that we've made.
We'll be going from start to finish, design on the old whiteboard, and then we'll be going through to some programming. We're going to be making graphics, sound effects, theme tune, deploying it to the web and testing it. Now, this isn't any ordinary single-player game. This is a mass multiplayer game. Lloyd came up with a number yesterday. Lloyd said the game's going to support 1,000 concurrent players. Now, if Lloyd's done the maths right, that's 1 followed by three zeros. Do you want to put that in scientific form just to help out?
That's easier to read.
Le 3, French.
That's even easier.
The three shouldn't be a superscript.
Should it be superscript?
Not in this syntax.
What is this?
Yeah. When you got the E, it's like that. You're thinking of like times 10 to the 3. We're doing this in Sharpie. There's no going back. We just have to throw this whiteboard out at the end. Lloyd, do you want to talk us through the game that we're going to be building? What are we going to be designing today?
The aim of the game is to avoid the letters that are falling down from the top. Just 0. It's just the 0 letter. 0 is not a letter. I recognize that, but it's a character. It's called zeros. So the game is you have a bunch of zeros here. These zeros are moving down the screen. This is going to players are here, so you are given a character as well. Maybe you're A, and you move across the screen here to try and avoid the zeros as they fall down.
Can you go up and down?
No.
No.
You can move left and right to avoid the zeros, as indicated by these arrows.
Okay, and where will all the other players be?
Well, there'll be like a B here, there'll be like a C here, maybe there'll be a few rows, and then you're all moving along the track. So these move down, but it looks like you're moving along because you can't tell. Whoever avoids the zeros for the longest wins. So the person who dies last wins.
When the zeros start to fall, are we just going to come in straight with loads of zeros, or are we going to start with fewer zeros and increase the number of zeros and therefore the difficulty over time?
Yeah, sounds like a good idea. Yeah, so that's the difficulty curve. If we draw a graph, difficulty is this axis and time is this axis. The longer you play, as time increases here, difficulty increases here.
That's good to know. And even in the professional world, still label your axis.
Y equals mx plus c. I don't know what the m and the x are, but
we can do it. This is what the difficulty starts at, and this is how much the difficulty increases over time. So that's literally what we're going to program to increase the difficulty.
It'll be the probability of 0 appearing is what the difficulty will appear as in the game. Probability will increase over time, which will be the difficulty as well, because there'll be more zeros to avoid.
So the way we're going to program this game, there will be a server running on the internet, which I'll represent here by a cloud, and then all the players will open up a web browser like that on their laptop.
Is that a B or a?
That's there's heat damage on the top of the laptop there.
Is that a grand piano?
They will, on their laptop or on their phone, they will connect to our website, and then we will give them a character, and then they will see the play field on their screen. And then as the game progresses, we will send player movement, we'll send back to the server, and then the server will say where the player now is and where all the other players are, so we can render that on the screen and how many lives they have.
Yeah, so it's all going to run on your web browser, so you're going to be able to actually play this game at the end or during, whenever we drop the URL, and you're going to be able to play with as many people who are watching and playing as well at the same time. And so you're all going to be able to play the game, and it will be on loop, so there'll be a new game as soon as the other ones finish, and hopefully we'll be able to support as many people playing as are watching, which could be 1e to the 3. You're going to see how games are made. At the moment, we're just doing the design where you have to agree with each other about what you want to do. Then we're going to look at creating the graphics, doing a little bit of the programming, how you make things work online, and the music.
So we're going to divide the work up between us. Lloyd's going to start off writing the front end, which means the bit that runs in the browser, the sort of graphics thing, and you're going to be using an in-browser graphics engine called Babylon.
Browsers can now do 3D, so we're going to be using a 3D but drawing in 2D.
I'm going to start off with the server-side network code, which will manage the game and work out who's winning and who's losing. And then we'll marry the two together and deploy it online. And then once we've done that, I'll probably go in and do some sound effects.
And I'll add some cool 3D graphics. Drop in any questions at any time, and we'll try and answer them.
We'll be in the chat.
We'll be in the chat as Foxdog something.
As Fox, yeah. I'm going to take the design away now, and Lloyd's going to start programming. So we're about an hour in now, and I've just laid down what's called the boilerplate for the project. Doesn't do anything yet, but there's just some basic foundations there on which to build. I open up this file. It says here, and that could be any message. Like, let me just change it to hello. And we run that in the web browser. Wait for it. That's built the website. Let's open that in the browser. There. Hello.
Where?
There. There's nothing actually on the website yet, but it has printed out the word hello.
So it's more like a secret.
It's an Easter egg. So my work here is done. Lloyd's going to take over and do the rest of the game.
On my one, actually, I've added it so that it actually says zeros online. Okay, so this is what we currently got. I've just put in just enough template to get the game started so that when you load it up, there's a button you can click, and this will allow us to actually play sound. That's what the sneaky thing is. So it says loading whilst their game actually loads in the background. You click play, and then we've just got a widescreen welcome to zeros. You're in the game. It doesn't do anything else at the moment, but we're definitely in it. Now we got a very exciting update where I can move this zero left and right. I'm just clicking there, and it's moving. And we put in a linear interpolation, which means basically there's a smooth movement between the positions. This is probably about the 5% of the way through the project mark. So that's 4 hours in. Oh, we just put in the following zeros. They're not quite in the right place at the moment. But at least, if anything, this now lives up to the name that there are zeros, lots of zeros on the screen. And you can see they're increasing in density as time goes on. In fact, in the code, just for a little bit of fun, there is a line. The M is 1 over 100. The C is 0.2. The X is the row number. So as the row number goes up, it's multiplied by 1 over 100 plus the constant of 0.2. So there's always a probability of 1 starting at the beginning. And, well, you can see this is probably a bit too high because now, only a minute or so in, we've now got a solid wall of zero. So we'll be wanting the zeros to come out a little bit slower than that.
We've just connected the server to the website. Let's have a look at that. So I'm going to start the web server program, which is written in C++. Now, this is a bit of the web server program. This is just a little snippet. When a player on a web browser connects to the web server, this piece of code is run here, and we allocate them a player ID. So what we will see in the browser is that when I refresh this page, it connects and it's allocated player ID 1, because this is the first player who's connected to the web server since I've run it. And if I refresh the page, we'll get ID 2. And if I open another one, we'll get 3. I could go on. Now we've got a connection between the web server and the website. I'm now going to make it send something useful. E.g., the player will be able to press the buttons left and right, and I'll know on the server where they actually are.
So what we got at the moment is lots of letters with a little 3 down here. We've registered with the server. So where it's loaded from is this file here, which is very, very hard to see, but these are letters here. They're white on a checkered background, but they're white because that allows us to change the color quite easily.
in the code, because we can put a tint on them, and because they're white, the colour will be applied. Because of the way that maths works with white, if they were black, we couldn't apply the light to them, couldn't apply the colour. So we've got these. This is in a grid, so I can fill up the rest of the grids with characters, and then different people, I choose to render this part of this image, and I can have them one texture. It's more efficient to have one texture on one material for all of these, so there's less cools to the graphics card, which makes it run faster. It allows us to have lots and lots of characters on one screen.
Now we have enabled online play. Well, online on the same network. So, and I click play here. See, there's two people, because we have both the 5 and the 3 ready to play, and I move with the 3 there, and you can see I'm moving on both. So this is in two separate browsers. Being able to see what the other person's up to. Flashes red when they get hit. So all we need to do now is start saying when the game started, so that they both start the game at the same time and they both are synced up. On the UI now, we've got some of the data that we're synchronizing. We've got in the top left the score of the player, which increments every time a row of zeros goes by. We've got the game ID, the GID, I just call it that for short, which shows the current ID of the game. So every time there's a new game, that will increase or change, so we know if we're in the current game or not, or we have to wait for the game to end and we can join in. Number of lives, 0, because they both managed to die. But if I refresh, well, I'm looking around, you can see that starts at 3, and as they hit zeros, it'll go down. The player game ID, which is 0, I'm not sure if that's right at the moment, but if that is equal to the current one, then we know that they're in this game. Otherwise, they need to wait for the next game. And the seed, which is the random seed that the server gives out, so we know how to generate the zeros. From here, all we need to do is start putting game state to know whether the game started or not. And then we could play the game, maybe. We've got now some information from the server about how long the game's been running for, which is the top left there, and also what state it's in. Using these bits of information, we're going to try and decide when to start the track, because at the moment we're just running the track right at the beginning. So we've got to see that when the game has started, we run the track. All the information is there.
So the server side code is complete, and I will give you a brief tour of that code. So this file, we use a thing called Google Protobuf to create the code that transports data from the server to the client and back again. This is the file here that describes those messages. Pretty simple. This is how the server sends the state of the game to the client. This is how the client sends information about what the player has done back to the server. Let's look at some of the key parts of the game engine on the server. So this is the code that updates the player. So when a player sends a message to the server saying, "I've lost a life, I've moved to a different column," this code is activated. First, we try and find that player based on their ID. Then we update their lives and we update their columns. If their lives have gone to 0, then we remember the point at which they died. Here's the part of the code that starts the game. First of all, we say, are there any players? If not, we don't start the game. Then we say, has there been at least one player for 10 seconds? So we stay in the lobby for 10 seconds before the game begins. Then we begin the game by setting each player's game ID to the current game ID and setting their lives back to 3. And now they're not dead, so we clear their dead at that time. This is how we progress a game, check whether a game has finished. We go through all of the players and check whether or not they have a life. If at least one player has a life, we're still in the game. If not, we set the game to finished and we remember the time at which the game ended. Here's what we do once the game is finished. This is the scoreboard section. So we stay on the scoreboard for 10 seconds. No, this is wrong. This code here finds the winner, but it shouldn't be here. It should be here. So as soon as the game ends, yeah, good bug fix, people. It's time to record the music. It's going to need 2 bits. It's going to need like a main game bit and a lobby bit. The lobby bit should be a sort of a quiet, calmer version of the main game theme. And when the lobby ends and the main game starts, you just kick in. I think it's going to be a sort of an electro piece with bass guitar, and that's because I have a bass guitar. So I've got a sort of a standard 4 to the floor electric drum beat. That's just to work over, just to get the feeling. Beefing that up with a filter and a compressor to make it sound like this. Then from there, and then it's going to be something like this, I feel. Something like that. I've laid down the sort of initial demo loop, which sounds like this. And now it's time to sort of work out a collection of highlights that we can drop in and out of the track. Okay, then it's time to add sort of like a high-pitched pad that we can bring in, and that sounds like this.
We've got both screens showing the same game at the moment. They are synchronized so that if one person quits one world, then they'll be able to be synchronized to be able to show the other persons. We've got this arrow which shows which player you are as well, to help guide the player to see which one they are. When there's lots of players on the screen, it may be helpful. And we've also got the game state going on. There's a lot of debug information written up at the moment, but if I manage to lose, it says game over. If I try and join during the game over, it still says game over, although I did fall down a little bit there. And then we're back here, welcome to zeros. Tap left and right to move. We're in the lobby. Once this gets to 10,000, this is a lap, which is in milliseconds, we'll see the game's begun. And it's going around again. Just need to put in the crown. The crown to show who won last time. Where's it gone?
Maybe it just hasn't redrawn. Yeah, it's gone. At some point during development, your laptop may stop charging. At that point, you need to take the back off and grab the soldering iron. Find yourself the broken bit on the charging socket and just touch the soldering iron to that and just reflow solder into the crack. Then, once you've done that, before you put it back together again, just give it a quick test.
And how often do you do this?
At the moment, I do this about once or twice a week. So now
sorry, is that just normal for anyone going into interest in game development? Is that what they can expect?
Yeah. It's normal in game development that you should have to do this, at least this. I actually do it less frequently than most developers. So let's do a test now. So we should see when I do this. Oh, I actually saw a little spark. So I haven't quite done it right, but you can see it is charging now.
Oh, I see that. We're looking at that light there.
It is charging there.
That's good.
Yeah, that means it's charging.
And that's what game developers have. They have those LEDs on.
Yeah. Better get back to work, hadn't I? At some point during the development of your game, your audio workshop might go completely grey like this. It's still playing audio, but it has gone completely grey. So what we have to do is force kill it and see how much work we lose. Okay, recover from crash. Yeah, that's quite a ways back. I'll check in later.
We now added one more feature, which is it'll show the crown of the winner. So you'll be able to track who's won the game. And this lets you know who you need to beat. I've hidden all the debug information. We're behind the G key. If you go on, you can press G. You can see some numbers that aren't really going to make much sense. But you can see your own player ID and the winner's player ID as well. And that's toggleable on and off, which is useful for a developer. So I can just quickly take a look. If there's a bug, I might be able to find out more about the bug by looking at some of the values of the variables inside my program.
It's about an hour later. I've just taken those drum beats and just dropped bits out of them to create different variations. And I've just put a filter over bits of the bass line. So this is going to be in it loop. I
added a feature that every great game needs, screen shake. When you hit a 0, I'm going to shake the screen a little bit. It's actually using the power of the sine curve. Who'd have thought it? Sine, maths, coming into play. So the camera rotates based on a sine curve.
Okay, so the music is in the game, and I created a simple intro loop that's just based on the music that's going to play at the start and at the end of the game. That sounds like this. And then we've got code here that when we transition to the game, it mixes from one to the other, and when we transition from the game, it mixes it back the other way. So let's look at that in action. We fade in the track, and then the new game is going to start in 4, 3, 2, 1. Then we mix back to the intro loop. Okay, we're down to the music. It's time for sound effects. I've added the crash sound effect. I've got to make some sound effects for going left and right. I think it's going to be these two notes. I'm going to try it out, so I'm just going to pretend that when I press the keyboard, this sound effect is playing by playing it at the same time.
Okay, so this is the game. We've uploaded it now to zeros.fds.im. We're just testing it out at the moment. I'm the 6, Pete's on the 4. Oh, snap. Oh! You can fit diagonally through them. If you want to tip, that's it. That's me done. Oh! I tagged the hit.
It's clocked in about 24 hours in total.
Hours. 2 12-hour sessions.
2 12-hour sessions, and you know what? I feel great. I think if you're going to be a game developer, the best way to do it is just to do just one long chunk.